Hi, chemistry students. This is your lesson on the reactivity of metals and nonmetals. A subtitle for this lesson could be, Why is the periodic table useful for prediction? You should take notes in your chemistry notebook and be ready to upload them for me today. This video was taped for January 4th, 2022. So the first thing you should write down is an idea of what's something called the periodic law. What is the periodic law? Well, the periodic law or periodicity states that when elements are arranged in order of increasing atomic number, their physical and chemical properties show a periodic pattern. And it's very useful to know about this pattern as you're thinking about how different kinds of elements react. Here's the second note. Elements in groups or columns on the periodic table usually react in a similar way because they have the same number of valence electrons. Now there are four groups 1, 2, 17, and 18, that you need to know by name. They have special names because they are so similar in their reactions. And again, the columns are the up and down, and so group 1 and 2 are the ones to the farthest to the left, and group 17 and 18 are the ones farthest to the right. So group 1, which are given the special name alkali metals, it starts with lithium, followed by sodium, potassium, and so forth down that first group on the periodic table. Group 1 is given the special name alkali metals. Alkali metals are very reactive metals, and reactivity increases as they get bigger. In other words, as you go down the column. Let's watch a little video here to show you the similarities of the metals in this family.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
Okay, just a few things to note. They were going down the group 1 from lithium to potassium. Because they have the same number of valence electrons, they have the same type of reaction, just a little bit more vigorous as you go down. They all produce, when you expose them to air, they rust really quickly. That's what that corrosion was on the surface of the metal. They're soft metals, and when you put them in water, they produce hydrogen gas. Now, the larger ones produce more. Hydrogen gas is very flammable. It's a very hot reaction, and that's why you get a more vigorous reaction. But the alkali metals react the same way because they have the same number of valence electrons. And that group 1 family is a particularly easy to predict what's going to happen as you go down the group. Okay, so group 1, alkali metals. Now let's look at group 2. Group 2 starts with beryllium, magnesium, calcium, and all the way down. Alkaline earth metals are also reactive metals, but they are less reactive than group 1. They also increase in reactivity as they get bigger. So let's take a look at this video. And again, compare and contrast the similar sized alkali metals in group 1 to the group 2. Notice how they're less reactive. But do notice that these metals do react and in a similar way, and they also get bigger. The reaction gets bigger as you get the bigger elements.
In this video, we will move down group 2 of the periodic table, looking at reactivity. The first metal in group 2 is beryllium, which is highly toxic and unreactive to either water or steam. The next metal down is magnesium. Magnesium reacts very slowly with cold water, but does react with steam, which we can see here. It forms a gas, hydrogen, which can be easily lit. And also the white powder, magnesium hydroxide, which can be seen here. After magnesium comes calcium, which does react with cold water, fizzing to produce hydrogen, and also the insoluble calcium hydroxide, which you can see precipitating out of solution here. We can demonstrate the production of calcium hydroxide by putting some calcium in universal indicator solution. As before, hydrogen is produced, giving a foam at the top of the cylinder, and also as the alkali calcium hydroxide is produced, we can see that the universal indicator solution gradually turns orange, then green, then blue, showing that the solution has now become alkaline. If we continue down group 2, we find strontium. This has to be stored under oil to stop it being oxidized by the air. The oil on the strontium causes the reaction to begin slowly, but gradually it picks up, and we can see that the strontium is reacting vigorously with the cold water. The bubbles, as ever, are hydrogen gas. You can also see some white particles in the solution. These are the slightly soluble strontium hydroxide. The next metal in the group is barium. This is slightly more reactive than strontium, and the reaction with water looks much the same.
Okay, again, you can see that there are similar reactions based on the fact that they have similar numbers of valence electrons. They all produce this hydrogen gas. You can see the reactivity as the element gets bigger also increases. So that's group 2 with the special name alkaline earth metals. So again, to sort of summarize, metals increase in reactivity as you go down these groups, but then as you go across, they decrease. In fact, the metals, the transition metals that come next, are not nearly as reactive, and you can understand that because most of the transition metals are things we use in buildings like iron, or in jewelry like gold and silver, and we certainly don't want those things to react. Now, another group that you need to know is group 17. They're called the halogens. And the halogens are all the way on the other side of the periodic table. They are very reactive nonmetals. They are less reactive as they get bigger. So they have sort of the opposite trend of what we saw with the alkali metals. In fact, the most reactive nonmetal on the periodic table, gas, is fluorine gas. Nonmetals have an opposite trend. But they do have a similar trend based on their identical valence electron structure. So let's look at the reactions of these now they have group 7 here, old-fashioned numbering. It's group 17, which starts with fluorine, and then chlorine, bromine, iodine, and so forth. They're called the halogens.
Group 7 of the periodic table is a group of non-metallic elements called the halogens. Iodine, bromine, chlorine, and fluorine are very reactive, so they're not found as free elements in nature. Fluorine is a gas, but it occurs in a rock called fluorspar as crystals of calcium fluoride. This is chlorine, a poisonous pale yellow gas. The commonest chlorine compound is sodium chloride, found as rock salt and in seawater. Bromine is a dense, poisonous, reddish-brown liquid which easily vaporizes and turns into a gas. Compounds of bromine are less common, but seawater is a source of many of them. Iodine is a solid. It has the appearance of shiny grey crystals. Iodine compounds are also associated with the sea. They're found in seaweed. Fluorine is too dangerous for us to handle. To compare the reactivity of the other halogens, we can see how they each react with the same metal. This is iron wool. For it to react with iodine, it's placed above a few crystals in a boiling tube, in a fume cupboard. Heating the iodine turns it into a vapour. A Bunsen flame gets the reaction going. After several minutes of strong heating, only a small amount of the iron has reacted. It's become coated with reddish-brown iron iodide. Put bromine in the tube instead of iodine, and it immediately vaporizes. Again, the iron wool needs heating, but not as much. This time, there's an easily visible reaction. A mixture of unreacted bromine and brown iron bromide pours out of the tube. Bromine is more reactive than iodine. It's above iodine in the periodic table. Chlorine is above bromine. So how reactive will chlorine be? The apparatus on the left generates a stream of chlorine gas. Concentrated hydrochloric acid is slowly dripped onto potassium permanganate.
You can see the chlorine gas forming there.
This time, the iron wool needs the slightest lick of a flame before a violent reaction races along. Clouds of pale yellow iron chloride quickly form. Chlorine.
All right, so I wanted to just, you saw these various reactions. Took a lot more for the iodine to get going than it did the chlorine gas. Now, the most reactive, what we call nonmetal on the periodic table, gas on the periodic table, is fluorine gas. They didn't even show you that because it's very hard to store it. It is so reactive, it is so dangerous in terms of explosiveness that they don't even people don't like to deal with it. So they have the opposite trend. But again, this group 17 here is called the halogen family. All right, last group that you need to know is group 18. They're called the noble gases. We've talked about this when we were talking about electron configuration. Noble gases are all non-reactive gases. They don't follow a trend of reactivity because they're not reactive. They have full valence electron levels, which means they are not inclined to react. Elements react in order to, with their valence electrons and in order to achieve a full valence electron level. And noble gases don't need to do that. This is just a fun little video. As they get bigger, though, they do get denser. We know that 1 mole of gas at standard temperature and pressure is 22.4 liters. So if you have the same volume, the gases are going to be denser as you go down. So watch how these balloons react. It's kind of funny.
Here are 5 of the 6 noble gases: helium, neon, argon, krypton, and xenon. They're all colourless and transparent. Krypton and xenon form compounds only with difficulty. Helium, neon, and argon don't form compounds at all. As we descend the group in the periodic table, the atomic number and the relative atomic mass increases. The gases get denser. Helium is lighter than air. Neon is just lighter. Argon and
krypton. I've just got to unstick these from the anchorage for a moment. Argon and krypton are both heavier than air. And xenon
is really heavier than air. It's really denser. Watch how it drops like a lead balloon.
Xenon is the heaviest of the lot. You've heard of a lead balloon? Well, this is it.
So I just thought that was kind of funny. But they're very non-reactive. All right, so here is the summary. The summary is that elements in the same column in the periodic table tend to react in a similar way because they have the same number of valence electrons. This should actually be number 3, I think. Groups 1, 2, 17, and 18 are so similar that they have their own special names. Other columns, we just say, you know, group 16 for the column that starts with oxygen, or group 15 for the column that starts with nitrogen, because they don't react as similarly. 1 and 2, 17 and 18, you do need to know these names. Group 1 being alkali metals, group 2 being alkaline earth metals, group 17 being the halogens, and group 18 being the noble gases. All right, now what I'm going to ask you to do is take a picture of your notes and upload them to the Canvas assignment. And that's it. Thanks for watching.